Alright, an airplane is descending as it approaches the airport and is flying at a height such that the pilot's eyes are located a distance of exactly 2 miles above the ground. The pilot is looking down at the control tower, which is approximately 0.06 miles tall and located exactly 6 miles away horizontally. A. What is the distance from the pilot's eyes to the top of the control tower? And B. What is the angle of depression from the pilot to the top of the control tower? Round your answers to the nearest hundredth. Select one answer choice for A and one answer choice for B. Okay. I'm actually going to shrink this and make this one bigger so that we can draw on it. Alright, so we have an airplane and it's descending as it approaches the airport and is flying at a height such that the pilot's eye, so this is the eye of the pilot, it's located 2 miles above the ground. So that's 2 miles. The pilot is looking down at a control tower. So he's looking down at some control tower. Right? And the height of this control tower is 0.06. I'm going to write that on the other side. It is 0.06 tall. So this whole height is 2 miles. This height is 0.06 miles. Now it says that it is located exactly 6 miles away horizontally. So horizontally, this is 6 miles. All right. It wants to know what is the distance from the pilot's eye to the top of the control tower. So from the eye to the top of the control tower, it wants to know this distance. And it wants to know what is the angle of depression from the pilot to the top of the control tower. Okay, so the angle of depression again is from our horizontal line that extends from our eye down to the line of sight. So it's talking about this angle. There is something interesting if we were to finish this and create our rectangle. These two angles from the horizontal line up, which is considered the angle of elevation, and from the horizontal line down, which is considered the angle of depression, they are the same measurement, because they are alternate interior angles between parallel lines that are being cut by a transversal. So they have the same measurement. So if we can find this angle of elevation, then we have found the measurement of the angle of depression. So let's solve this for our distance. So I'm thinking to myself, okay, well, this is a right triangle right in here. And I have 6 miles, and I actually have this length. It is not 2 miles, though. It is 2 miles minus that 0.06, so it would be 1.04. I just want to make sure that 1.94. It's a good thing I double-checked. So we know that this length is 1.94. The reason why is because this is 0.06 miles tall, the control tower, and the total length from the pilot's eye to the ground, which was including that, was 2 miles. So we subtracted it, and it's 1.94 remaining. So that's how tall this leg of the triangle is. And then we have 6 miles. Right there. So we have a right triangle. There's two ways we can solve for a side length in a right triangle. We can do Pythagorean theorem or we can do trig functions. Again, Pythagorean theorem requires two known side lengths. which we do have. We have 1.94 and 6 miles. So let's just jump into the Pythagorean theorem. Again, remember, it's a squared plus b squared equals c squared, where c has to be the hypotenuse. So I'm just going to label this c instead of our, which is our x, side length. So now let's just do some substitution, or label the other sides. This side is A and this side is B. It doesn't matter what order they go. So now let's do the substitution. AI side length is 1.94, and that's squared, plus B's side length was 6 miles, so that was 6 squared, and that equals, well, C was our hypotenuse, and we had labeled it x, and that was x squared. So now I'm going to jump over to the symbol lab and type it in. 1.94 being squared plus 6 being squared is equal to C being squared. Again, I want you to focus, x being squared. I want you to focus on the relationships in this course, and if algebra wasn't the strong suit, then this will help us with the steps. So it says to switch sides. It's not a necessary step, it's just part of their algorithm. They like to have what they're solving for on the left-hand side. So then they're saying 1.94 squared is 3.7636, so that's how they went from 1.94 squared to 3.7636. And then 6 squared is equal to 36, so that's how they went from this 6 squared to 36. We add the numbers, 3.763 plus 36, and that equals 39.7636. So then that's how they went from this step to this step. And so now this is just saying that when you have an x squared, the solutions are the square root of that right-hand side and the negative square root of the right-hand side. So we have x equals the square root of 39.7636, and x is equal to negative square root of 39.736. Sorry, that came out wrong, but you get the point. So the question is, when you're talking about distance, can you have a negative distance? The answer is no, so we will be looking only at this positive solution. If you come up here, it gives us these solutions up here, and then it gives us the decimal. X is equal to 6.305, and in this it says round to the nearest hundredth. So we would go to our thousandth, which is this 5 and up, you round up, so this is 6.31. So our x is equal to 6.31. So the length from the pilot's eye to the top of the tower is 6.31 miles. And now it says, what is the angle of depression from the pilot to the top of the control tower? So again, remember that I had at the beginning said that the angle of elevation and the angle of depression have the exact same angle measure because they're alternate interior angles in this rectangle. And alternate interior angles have the same angle measure. So if we find this angle measure, which is located inside the triangle, we can find the angle of depression. Or you could say, well, I want to focus on the angle of depression, so let's label these other two sides of that rectangle, which would be easy since these two side lengths are the same in a rectangle, and these two side lengths are the same in a rectangle. So let's go that route. This is our angle of depression. Here's the 90-degree angle. Let's label our triangle based on our angle of depression now. So we have this angle, the side length opposite it is the opposite side length. The side length across from the 90-degree angle is the hypotenuse, still the hypotenuse, and the one touching the angle and is not the hypotenuse is the adjacent side length. So, again, remember when you're finding an angle, you're going to be using inverse trig functions. So you're going to have the option that the angle is going to equal sine inverse. And again, remember, sine doesn't change its ratio. It still stays opposite divided by hypotenuse. So sine inverse would still be opposite over hypotenuse. Or we have the choice that our angle could be using the cosine inverse of the adjacent divided by the hypotenuse. Or the angle could be tangent inverse of opposite divided by adjacent. So just remember, when you're finding an angle, you're using inverse trig functions. So let's look at what they gave us. We have an adjacent side length, which is 6, and an opposite side length, which is 1.94. So I'm going to be looking for one of these that has the relationship between the adjacent and the opposite. This is opposite and hypotenuse, so it only has one of them, so I'm not going to choose this one. This one's adjacent divided by hypotenuse. Again, it only has one of them. It has the adjacent side length. This is opposite and adjacent. Has both of them. It has the opposite side length and the adjacent side length. So that's the one we're going to use. So we have our angle is going to equal tangent inverse of the opposite side length is 1.94 and the adjacent side length is 6. So now we're going to jump over to Symbol Lab and do tangent inverse. And I just paused after I typed in tangent, T-A-N, and it brings that up. I don't want to have 1, I want to have 1.94 divided by 6. And so notice that it gives us in decimal and in degrees. We want it in degrees. It's 17.91 degrees. And this one's 17.92, which is our closest one, so there's our answer. So again, this angle of depression is 17.92 degrees. And that's how I would answer this question.